Good afternoon, everyone. John Ostrom with Bird Strike Committee USA. I'd like to welcome you to our second webinar in the Strike Zone series. Today, we're glad to have Dr. Jay Tischendorf give a presentation on the wild world of zoonotic disease. Jay has been around for quite a while, and just want to go over a little bit before I do an introduction of how things are going to proceed today. All of your microphones have been muted and you do not have the ability to unmute. So I would ask that if you have any questions, please shoot them or put them in chat, or else you can actually send them to me at john.ostrom@mspmac.org, and that information is in the chat window, timed at 12:56. So as Jay gives his presentation, we'll hold all questions to the end, and then I will read the questions, or Jay can read the questions depending how they're submitted, and we'll have an opportunity to hear what Jay says. So we're looking for a very productive webinar this afternoon. And with that, I'd like to introduce Dr. Jay Tischendorf. Jay is a veterinarian and wildlife biologist who works in both the natural resources conservation field and the pharmaceutical industry. He's passionate about educating people on the dangers of infections and zoonotic diseases, and speaks widely and in many cases energetically on this subject to audiences ranging from fellow medical and natural resource professionals to nuisance wildlife operators and animal control officers. His work has taken him from coast to coast and into Canada and Central America. Dr. Jay is a former U.S. Marine, EMT, and wildland firefighter, both hotshot and helitac. He splits his time between Montana, Texas, Kansas, and Maine. And I'd like to give a rousing welcome to Jay. Jay, thank you for joining us here this afternoon. So, Jay, whenever you're ready to share your screen, it is all yours.
All right. Well, let me see if I can get that screen shared. Bear with me just a sec here. Let's do an application window.
And just a reminder for everyone, the session is being recorded, and Bird Strike Committee USA will make the recording and or link available so that you can view at your leisure.
All right, John, I think we're getting it here. Do you see the PowerPoint?
We do.
Awesome. Well, super duper. We're off to a good start so far. Okay. Well, hey, everybody, Happy New Year. Thank you so much. Special thanks to John and James Laughlin, in particular, members of the Bird Strike Committee, who really are the brains behind this, put this all together for us. And I'm honored and flattered to be here today. And I appreciate everybody taking a little bit of time out of your busy days and lives to join in and hear about zoonotic disease. It's always nice for me to share my passion for this subject with fellow wildlifers. And so without too much further ado, we're going to dive into this. And as John said, I hope there's some questions at the end, and we don't want anybody to leave disappointed, okay? Got to give a shout out to Lisa with Bird Strike Committee. Meet and Hunt was also instrumental. She's the IT whiz behind all of this with the Facebook page that the Bird Strike Committee has. And then my good friends, Bill Antonides, Rusta Fusco, Cody Bachuska, Steve Freisel, and John Weller, all of whom are instrumental in getting me involved in wildlife aviation hazards, gosh, almost 10 years ago, or 10 or 11 years ago at this point. So I know some of those folks are on the call today, so thanks so much for that. But yeah, what a wonderful group of people. Do want to give a shout out to the National Wildlife Control Operators Association, or NACOA. Those of you engaged in wildlife control in any form or fashion, this is an organization you absolutely must consider joining. I actually do a full day-long zoonotic disease awareness course through NACOA in partnership with NACOA, and you can see the emblem there, that hazmat emblem. We've got a cool patch and decals that go to the graduates of that course. But if I whet your appetite or wet your whistle with the subject of zoonotic disease in this world of microbial mayhem in which we live today and have always lived, then please consider signing up for that class. And even as a non-member of NACOA, you can take that course. I think the next iteration is going to come around in late February when NACOA has its annual expo, which in this case they've canceled, but they have offered in place of that some different training opportunities. So check out their website and give them a look if you're not familiar with. Great organization. I run the American Ecological Research Institute, and as John mentioned, I've got my hands in a lot of different things that I'm passionate about. And I feel very fortunate that I've been able to stay active in wildlife and my work in the pharmaceutical industry as well. Feel real fortunate to be a veterinarian and a wildlife biologist. Well, guys, without further ado, let's get into this. You know, it was eons ago, many millennia ago, that a philosopher, mathematician named Archimedes said, "Give me a lever and a place to set it, and I will move the earth." Well, today I would argue that you give me a microbe and I will shut the world down. In fact, that's what we see today with the pandemic that is upon us. If you missed the memo, didn't get the invitation, heads up, there's a party going on. It's the Corona family. They've invited all of us, and in some cases, we actually may be on their menu. But yeah, this is the world we live in, folks, this pandemic. And long before the pandemic hit with Corona, oh, I should mention too, you know, when I was a kid, we played board games like Monopoly and Clue and Hooks and Ladders and things like that. Today, there's a pandemic board game that somebody's come up with, a sign of the times in which we live. So, you know, not quite as uplifting as Monopoly or Clue or Hooks and Ladders, Shoots and Ladders, but that's the world we live in. And so if you haven't figured it out by now, I truly believe, and I think the evidence supports that we do live in a world where we are always surrounded by microbes. We always have been, we always will be. Some will be less concerning than others, but there is always that risk of infectious disease. And important to note that most infectious disease of concern to humans is in fact zoonotic. The majority of infectious diseases that humans deal with or contend with actually are zoonotic. And that means those are diseases that are shared between animals and people, transmitted between animals and people, or shared by wildlife reservoirs and parasites. And we'll talk about ticks and things a bit later on, but those two fall into that category. So in our lives forever and always, you know, till death do us part. And in some cases, that's sooner than we would like. All right, our plan for the day, I hope to unlock for you some of these mysteries and the mystique surrounding infectious and zoonotic disease, our who, what, and where as this microbial cast of characters. We're going to talk about some different diseases, some different vectors of disease, some different microbes. What I'm going to try to highlight some new things that are exciting and perhaps concerning out there in this world of microbes and microbial mayhem. And our area of concern is basically planet Earth. I'm going to lead you on a little global tour, mostly focused on North America, but we're going to go around the world. When I talk about microbes or pathogens, I want everybody to just understand there's really only 6 or 7 different causes of infectious disease. Yeah, there's, you know, thousands of infectious disease, probably upwards of 2,000 different diseases of concern to humans, but really there's only 6 or 7 causes, and those are bacteria, fungus, and algae. I lump those into the same category. Parasites, things like worms, right? The Balis ascaris roundworm or the canine roundworm, something like that. The tapeworm, things like that. Prions, infectious proteins, chronic wasting disease would be an example, or mad cow BSC is perhaps better because that's demonstrably proven to be zoonotic. So far, chronic wasting disease hasn't, although I'm not necessarily holding my breath on that. It could well prove to be, as other prion diseases have. Protozoa, so things like Giardia, Coccidia, Cryptosporidia, those are protozoal. Toxoplasmosis is another. And then viruses, and that would include things like rabies, coronavirus, the norovirus, not necessarily zoonotic, but that plagued the cruise ship industry well before the pandemic hit. And now, coupled with the pandemic, that whole industry is pretty well gone by the wayside. But yeah, lots of different viruses. Influenza, perhaps, is the best example. All right, so if you haven't figured it out, again, it is a wild world out there, hence the title of our talk today. And even as the pandemic has been raging around the world, those of us that keep up with these things have noted that there's other diseases that also are causing issues. This was over in India, a strange, mysterious disease that showed up, and I don't know if it's run its course yet or not, but at the time, nobody was quite sure what was going on. It may have been toxicologically related rather than an infectious organism, but interesting that there are mystery diseases still similar to COVID or the SARS-CoV-2 that are showing up. Those of you that deal with bats, and by the way, NACOA has a wonderful series of bat training workshops that they do, similar to the zoonotic disease program that I offer. But those of you that work with bats may have been aware, or perhaps not, that a new bat tick was discovered. This is a soft tick, different from most of the ticks that we're concerned about in the wildlife world. But this showed up on bats in New Jersey. It had been found in other states in the Union, in the United States already, but this was a first for New Jersey. So these microbes, these pathogens, these vectors, these parasites continue to show us new capabilities and show up in places where we might not have expected them. But what is concerning here is that tick feeding on the blood or tissue fluid or fluids of bats potentially could be picking up things that bats are carrying and then potentially transmitting those same things to us if they happen to feed upon us. All right. This was a strange, highly infectious, highly fatal disease in Bolivia that showed up. It's reared its head several times over several decades and quite mysterious, seems to be linked to rodents, very similar to hantavirus, which we have here in several different forms in North America. But hantaviruses are found all over the globe, and this seems to be one that really nobody has much familiarity with in Bolivia. They call it the Chaparral hemorrhagic fever, and the CDC, and I'll just give a shout out to the CDC. If you ever have a question about zoonotic disease, I'm always happy to offer what input I can, but the CDC, Centers for Disease Control, cdc.gov, is a great website to search for information on zoonotic and infectious disease. They've been under the gun with the pandemic and, some criticism of, how they did something or didn't do something, but I still maintain it is the world's most foremost and authoritative agency or group of people with expertise in this same subject. So this is something else that's been circulating sort of under the radar of most people, but a salmonella epidemic of sorts in pet hedgehogs and lizards. This has smoldered along for many decades, off and on, but lately there's been an upsurge in hedgehogs with salmonella, transmitting that to their, pet owners that like cuddling and snuggling with their little friendly hedgehogs. I'm a veterinarian, I get it, but some may wonder why you'd want to cuddle and snuggle with a hedgehog. But we'll save that for another talk on another occasion. Hey, West Nile virus. Some of you are old enough to remember when that showed up on the scene back in about 1999 or 2000 at the Bronx Zoo. A veterinary pathologist there who was on her game actually was the first to figure out what exactly was going on with dying birds. And at that point, I think they'd already had some human cases. But in short order, that virus, West Nile virus, WNV, circulated across the entire continent. And although it's sort of fallen off the radar screen for a lot of folks, every year it causes not just illness, but in fact, some deaths of people. This is transmitted by mosquitoes. And one of several reminders I'll give you today, exactly why we want to protect ourselves against these biting insects, whether that's flies, fleas, ticks, mosquitoes, the Chagas bug or the kissing bug, assassin bug that we'll talk about here in a little bit too. Any of those things that want to feed upon us, Count Dracula, maggots, anything that want bed bugs, anything that wants to eat our blood and feed on our bodies is a good thing to prevent, okay, for any number of different reasons, West Nile virus being one of those. And lest you think I'm biased, this is my own county here in Texas, where I live. This is Montgomery County, north of Houston, where we too have to deal with West Nile virus and had our own death, at least one death last year in 2020. And that was last fall here in October, just recently. Along the way too, in the midst of this pandemic, researchers have been discovering new coronaviruses. There's many out there, some of which we know of and many others, which I'm sure we don't, and perhaps others that will emerge through evolution and mutation and whatnot. But this is one that's of interest. It was discovered in Cambodia and Japan, very similar to the SARS-CoV-2. And so, perhaps an opportunity to learn from this and study it and maybe gather more information about COVID-2, and also then figure out if that new coronavirus is in fact zoonotic like the SARS-CoV-2 or COVID-19 has been. Good segue here too, folks. You note the headline here, and Dr. Fauci, who I have very high respect for, despite the fact he's been beat up in the world today in the political arena, which I think is completely inappropriate. But he's commenting here on the mutations that we're now seeing at seems to be a higher increasing rate with COVID-19 or the SARS-CoV-2 virus. This is concerning, and it's a reminder for me to mention that in all of my presentations, I always like to say that the headlines with these diseases, especially these newly discovered diseases, rarely get better, at least early on in the progression of things. And here we are a year into this pandemic, and we're still seeing headlines that continue to be concerning. My guess, my prediction, and sad to say, if you're hoping for good news, I don't have it. It's my opinion that these mutations are eventually going to prove to be very problematic. At least some of them or one of them will be. And we'll find that our vaccines, that these companies like Pfizer, Moderna, and most recently coming to market right in the torpedo tubes is a Johnson & Johnson J&J vaccine, which is cool because it stands to be a single dose vaccine. But my sense is, knowing what I know and the patterns I've seen over many decades with this type of work and studying the history of these diseases, that eventually there will be mutations in the COVID-19 virus that render it immune or able to avoid the vaccine. So stay tuned. Let's hope that doesn't happen, but brace yourselves. As I say, the headlines rarely get better. And that's my sense is what we're going to find eventually. Not to say you don't want to get vaccinated. I would as soon as you can. That's my recommendation for any disease that we can protect ourselves and, for that matter, our animals against. Let's maximize vaccines for the right reasons. Use them where we have that tool, because there aren't actually many diseases that we have vaccines for. So I encourage everybody, maximize the appropriate use of vaccines. Yes, they are medical instruments. No, they are not perfect, but yes, they do provide a lot of benefit, and for the most part are really quite safe. And so that's my take on vaccines. I talk for about an hour in the day-long course, much more in depth on that subject. But yeah, bottom line here, watch the headlines. I almost guarantee they're not going to get better with COVID-2 anytime soon. On that note, then, here's some things to consider as we talk about these microbes, these pathogens that we battle and have been battling since day one, since man came onto the planet and encountered all of the microbes, that pathologic stew that was already there waiting for us, and in some cases adding us to their recipes and stew pots. There are some amazing capabilities. This is a bacteria that researchers took up into space with them, and it has survived up in space in that crazy environment, habitat of space, way outside its normal habitats. And yet this bacteria has not necessarily, or has survived and perhaps even arguably thrived. So that's pretty amazing when you think of it. Outside of the spacecraft, I should have mentioned, that's not sitting inside the spacecraft with all of the atmospheric controls. It's out on the side of the spacecraft in a little culture dish or something. So pretty incredible. Radiation, heat, cold, whatever, and that bacteria survived. Here's another bacteria. This was found in the hot springs in Yellowstone Park and subsequently has been found in hot springs all over the world. This bacteria actually spends its entire life somewhere in the vicinity of 191 degrees Fahrenheit, just shy of the boiling point of water. And this bacteria is quite happy to live at that temperature that would immediately kill any one of us, all of us, in a matter of seconds, if not minutes, if we spent excessive time there. So again, amazing capabilities in these microbes, not necessarily zoonotic ones here, but it does demonstrate some of the things that we may be up against. Have any of you ever heard of anthrax? And I'm not talking about the hard rock, acid, heavy metal band, but the bacteria. This is interesting in my crazy world, and call me crazy, but I think it is fascinating. Some of you may remember when anthrax showed up in the news, oh gosh, probably 10 years ago, some A mysterious white powder was showing up in envelopes addressed to federal officials and so on. I don't know if that crime was ever solved, but in fact, anthrax, like a lot of the zoonotic pathogens we talk about, is a weapon, a bioweapon, potential bioweapon, weapon of mass destruction in its own right. And so that's true for a lot of these zoonotic microbes we talk about. They could be very, very easily weaponized for biological warfare. In the case of anthrax, what's really amazing is this bacteria actually has the ability to form a very hardy, long-lived spore. It's basically in suspended animation, and it can survive for a long, long time. It's found virtually all over the world, with the exception of some of the Arctic and Antarctic type regions, but very commonly found in Africa, even here in the United States to some extent, typically in the southern tier of the states, but widely distributed. Its spores, when exposed to oxygen, or they get into a host, like say a ruminant, a cow or a horse or animal that comes along and is feeding on grass, or somehow ingests some dirt, or perhaps gets dirt into a cut, those spores then activate and become, full-blown infective, causing disease in some cases, and potentially being then transmitted and passed on to other folks if that animal, that carcass, is handled or eaten and not properly prepared or heated. So pretty amazing when they call it the Siberian plague or the permafrost plague, because areas where these spores have been frozen, not just for weeks, months, or years, but in fact decades, this bacteria can remain alive in that suspended animation stage, are now, those spores are emerging to the surface with thawing and things like that. And people doing things like this, drinking blood of animals in some cultural traditions, etc., not something I recommend. I'm also careful about sushi, and I encourage all of you guys and gals to be careful about sushi. Eating anything raw is probably concerning, any meat anyway. But habits and cultural traditions, practices like this don't necessarily impart a lot of safety. Any number of different pathogens that Inuit or that native is potentially going to get by drinking, raw blood from the source. So just again, some things we don't want to do. Speaking of the permafrost in Alaska and the tundra, the Spanish flu virus, the influenza A strain that caused the Spanish flu, what I call the great zombie apocalypse of all time, was discovered and confirmed in a human cadaver taken out of the permafrost. That virus was inactivated after all these years, but it allowed researchers to figure out its genetic footprint or fingerprint so they could determine exactly what it was. And scary enough, its potential, if that fell into the wrong hands, it could be reverse engineered and bioengineered and unleashed upon humanity again. I'll say that it is not a question of if, but in fact, when the next pandemic will hit. This is not the last one. I hate to say that we're lucky with COVID-19, but in many ways, it's a fairly mild pathogen compared to what we could have seen with something like the Spanish flu and its incredible virulence that wiped out 10% of the global population in 2 short years, circulating from where it started in Kansas, United States. We like to call it the Spanish flu to deflect and distract people from understanding that it actually started in Kansas, probably an avian flu transmitted to swine, where it then again mutated and became infectious to humans, and perhaps again mutated and became infectious between humans. But it's just a question of when, not if, the next pandemic will hit. So if we don't learn from this one, shame on us. But this is the world I live in. And in fact, we all do. So brace yourselves. This stuff is out there. And as I said, it always will be. People have speculated often to me. They've said that, they thought Lyme disease was something, again, we get into the, infectious disease conspiracy theory, as if there isn't already enough of that out there. But people have said they've heard or they believe that Borrelia burgdorferi, the bacteria that causes Lyme disease, was a human engineered pathogen unleashed on the wildlife reservoirs and the white-tailed deer, society up in New England initially to control whatever populations, humans, animals, or whatever. The fact is, Borrelia bacteria have been found way back in fossils in fossilized ticks going back again many, many, many millennia. And so, folks, these pathogens, many of them have been around for eons, slowly adapting or just never changing because they're already quite successful. But yeah, if you ask me, I don't think Borrelia burgdorferi, the causative agent of Lyme disease, was human engineered. I think it's been among us for a long, long time. And with the changing demographics of human society and wildlife coupled, we reached a perfect storm where that bacteria really began to spread among people. So that's a nice segue to talk a little bit more about vector-borne disease. These are diseases transmitted by parasites like flies, fleas, ticks, things like that. We call those the vectors, these biological messengers that can pass pathogens and microbes on from an animal to us. In some, pure definition of zoonotic disease, for example, Lyme disease, some people might say, well, that's not really zoonotic because you don't get it directly from the animal. You get it from the tick that may have bitten an animal and then bites you. I don't make a whole lot of distinction. And frankly, I just consider tick part of the wildlife anyway. So in my mind, a tick is an animal of sorts. And so if I get a disease from that tick or get the same disease that it might have transmitted to a deer or picked up from a deer, or whatever, it's all the same to me. But there are some distinctions there that people might make. And I'll just share those. I share those with you so you're aware. Mention some of these vectors, things like ticks, flies, fleas. There's the triatomine bug there on the bottom. That is also the assassin bug or kissing bug that we'll talk about with Chagas disease, which is emerging here in North America, particularly where I live. Texas is like disease central, infectious disease central in the United States. I think we were the first state to have a Zika virus case show up in North America, and so on and so forth. It goes on and on. Lots of different diseases seem to make their appearance first here in Texas. Chiggers are on there. I'm not sure that they have a zoonotic concern, not that I know of. Same with bed bugs. But I did mention earlier, I'm concerned about any organism that wants to feed upon my blood or that of my family members or pets. And so I do take things as, as seemingly innocuous and just uncomfortable as chiggers pretty darn seriously, just because I think there's a lot of potential for transmission of microbes. If we don't know about that microbe today, it's one we're going to discover tomorrow and read about, often accompanied by a death, a mysterious death. And so protect ourselves against any biting insects all the time, everywhere. This is kind of interesting. This is the new tick that's shown up, the new kid on the block, the new tick on the block. It's the Asiatic longhorn tick. Probably came over here into North America somehow, probably about 10 years ago, perhaps 15. It's recently been documented in New Jersey and now increasingly other states. What's fascinating about this tick, well, and like many ticks, it has the capability to transmit a heck of a lot of diseases. In fact, ticks, although they don't kill more people than mosquitoes are arguably the most dangerous creature on earth. They kill more people through things like malaria overseas and around the world than any other insect or any other creature, including, crocodiles, sharks, grizzly bears, rattlesnakes, whatever. Ticks actually carry and transmit a greater variety of diseases. They just don't happen to kill as many people. But what's interesting also about this Asian longhorn tick is that it can reproduce through parthenogenesis. And if you go back to your biological training, you may remember that's, a female able to give birth to young without having sexual relations with a male. So pretty amazing and also terrifying, because all you need is one female tick and she could populate an entire area, a new habitat with her offspring without even having to have a male tick anywhere in the vicinity. So that's pretty darn scary. And we don't really still know all the diseases that this tick might be capable of transmitting that are already here in North America, nor do we necessarily fully appreciate diseases that the ticks brought with them when they were first introduced de novo. So in the first place, when they first came here. So some questions there, things to think about. Also worth noting, we talk about all the different diseases that ticks can transmit around the world. Of course, here in North America, Lyme disease is probably the most well-known, although arguably not necessarily the most concerning. But what is interesting here is the CDC, 5-10 years ago, actually acknowledged oops, we've goofed. There's a heck of a lot more Lyme disease out there, more cases than we've ever realized. And in fact, it may be upwards of 10 times more cases than we've appreciated, 10 times more cases than are being reported, 10 times more cases than are being documented. That's kind of a scary thing to consider. And I'll share with you some graphs that demonstrate how significant that could be. This is a state by state representation. This goes back a few years, back to 2014 or so. I doubt much has changed other than the number of cases, but Pennsylvania, Massachusetts, New York, New Jersey, Connecticut, in the East tend to be highly problematic, not to say the other states aren't, but in terms of actual case count, and this is not necessarily per capita, this is just absolute numbers of cases. And yeah, arguably Pennsylvania has more people than New Jersey, so you might expect more, but in any case, this is something to think about here. And then upper Midwest, so Minnesota shows up with a lot of Lyme cases. Wisconsin, we get up then back into New England and the Atlantic seaboard with Maine and Maryland. But the point is, Lyme disease is well dispersed. It started there in Old Lyme, Connecticut, or Lyme, Connecticut, where it was first discovered or elucidated in a group of children that came down with pediatric arthritis-like signs, and doctors and mothers got concerned and figured out, hey, this isn't a rash of, excuse me, I should say an epidemic of pediatric arthritis. It's actually an infectious disease. And in some cases, actually, it was accompanied by a rash, that characteristic bullseye rash that we often associate with Lyme, although it doesn't show up in every case. But since then, that disease, you know, being somewhat localized in New England, has now spread. And I've got some maps here that'll show you. But that north central, upper Midwest is the other primary hotspot for Lyme disease, as you see here. Green being the highest ranking states for the number of cases, yellow being the lower ranking states. And not to say in the yellow states they don't have Lyme, they just don't have as much as they do in the green. And I've got several maps here that demonstrate, kind of give you different visuals because people learn different ways. But look at the case count from, say, 1991 all the way up to 2017 in this bar graph chart. Part of the issue is, yes, there are more cases being documented, but some of that is simply because of every year we seem to have more awareness that we need to be doing a better job looking for cases. And so it's sometimes difficult in these discussions to tease out, you know, how much are we seeing just more Lyme cases because there's more Lyme out there, versus how much are we seeing increased cases because we're just more attuned to looking for them. But in any case, it is what it is. And again, a disease you don't want to get if you can avoid it. And the way to do that is protect yourself against tick bites. By the way, those ticks, as I sort of alluded to earlier, are transmitting oftentimes not just one pathogen like Lyme, but several, perhaps many. So just protect yourself against any tick, anytime, everywhere, any life stage of any tick, anytime, anywhere. And at the same time, hopefully you're protecting yourself against mosquitoes, biting flies, biting mosquitoes, fleas, etc. So here's another way of looking at those Lyme cases. Again, you see the New England, the Mid-Atlantic or Atlantic seaboard, and then up in the North Central, that blood red color is where you don't want to be. That's where we have the preponderance of cases. But you see there are Lyme cases dispersed even throughout the fairly arid Great Plains and central states where we don't necessarily think of that as being, you know, great tick habitat, at least not for the deer tick. There are other ticks out there. And at some point we may discover that they too have developed the capability of transmitting Lyme disease. But certainly those other ticks are transmitting other diseases that I'll show you a map here in just a sec. And then even on the West Coast, that Western black-legged tick or Pacific black-legged tick out there, a close relative of the Eastern deer tick or Eastern, the true black-legged tick, able to transmit Borrelia burgdorferi, that causative agent of Lyme. There's a new test that's in development that promises to be better at diagnosing Lyme, so we may see even more cases getting diagnosed with this, on top of the fact that, you know, the CDC acknowledges we've vastly underestimated the prevalence of this. You know, we see the tip of the iceberg with cases that get diagnosed. How many people out there have been bitten by ticks? They don't feel well. They've got something going on. Maybe their immune system kicks it somehow, gets rid of it, clears it, or they just have lifelong issues potentially and whatever, but they never get an official diagnosis. So Lots of things we don't understand. Here's a map that shows some of the other tick-borne diseases. This is not all the diseases that we have with ticks in North America, but it's representative of some of the bigger ones, the Ehrlichias, the Anaplasmas, the babesiosis, tularemia or rabbit fever. And again, pretty well parallels what we see for Lyme disease with the black-legged tick, the New England, the Atlantic seaboard, and up into the North Central. But here too, lots of cases right in the heart of the Midwest there with Missouri, Arkansas, Southern Illinois, and Northern Alabama, et cetera. So Tennessee, et cetera. So again, no place is safe. Take tick seriously no matter where you're at. And I rarely get wrapped around the axle with, the arguments and discussions about, is it this tick or that tick? Yeah, it's nice to know, and I can identify ticks if you want me to. My take is just be careful with all ticks, because as I've said earlier, if it's not transmitting a disease we know of today, I don't care what species of tick it is or what life stage of what species of tick it is, it's transmitting something we're going to discover tomorrow. That's the way I look at it. And I just don't want to take chances with any of those biting insects. And interestingly, if we superimpose populations of white-tailed deer, which of course have surged in the last decades, in the early 1900s, deer were almost eradicated. And by the 50s, say 1950s, 60s, we're starting to come back, and there were some restoration efforts in some areas that helped. And then, changing demographics and whatnot, et cetera. So deer have really surged, but let's compare some maps and superimpose white-tailed deer populations side by side with our tick diseases. And you see there's a pretty astounding overlap here. And in my estimation, this is not just correlation, this is cause and effect, that, deer provide a great source of blood meals for ticks of any species. And certainly some species of ticks seem to prefer deer, but they figure prominently into the story of tick and tick-borne, vector-borne disease here in North America. So really, deer management, I think, has to take all of this into consideration, and we may need to change our tunes that we're singing in regard to deer hunting and deer populations, et cetera. So it's kind of cool to look at that. And again, I mentioned new diseases being discovered. Here's a great example just in the recent past. This was back in November. So literally just 2 or 3 months ago, experts have now discovered a new rickettsia species. This is a type of bacteria closely related to that causes Rocky Mountain spotted fever, or the Ehrlichia complex in people and animals. This has been found in dogs, but rest assured, guys, it probably didn't just show up organically and evolve organically in dogs. It probably derives from wildlife, and so there's more of it circulating out there. It just happens that a handful of dogs stumbled into it, or stumbled into the ticks that were transmitting this. And now we've got some cases that are documented in our domestic animals. Here's the scientific article that talked about that. And you don't have to look too far, too wide, or too deep to find articles like this fairly frequently in the literature. So as I say, it seems, if not every month, every few months, and certainly every year these days, the CDC and other expert groups are discovering or talking about newly discovered infectious zoonotic diseases. And dollars to donuts, most of the time, they're vector-borne diseases, most of the time linked back to ticks, all right? Spotted fever, this was this new agent. The experts, the medical professionals, veterinarians like myself, thought it looked like Rocky Mountain spotted fever, but when tested, it wasn't that same Rocky Mountain spotted fever bacteria, rickettsia. It was a different type of rickettsia. So, oh no, hold the phone. What the heck's going on? How bad is this one going to prove to be? Again, in my opinion, the headlines aren't going to get better about this, but it's another great reminder that, again, wildlife reservoirs out there, and I love wildlife, but they do, have potential problems and public health concerns for all of us and our fellow man and woman in our society. We need to find ways to coexist. I'm not saying we want to eradicate wildlife. By no means. I've dedicated my life to saving endangered species in particular, but we need to be aware. And those of us that handle wildlife regularly or work with wildlife and domestic animals regularly are certainly at heightened risk for any of these diseases. And you never want to be that case report written up, as the first victim or first case that somebody figures out because oftentimes those cases are accompanied by a fatality report and obituary, and you don't want to go there if you don't have to. Another newly described rickettsia, this was out in the Northwest a couple years ago, 364D, in a case of some example of what it might cause in you or a family member or somebody that gets this, these eschars, these canker-like sores on the external skin, and perhaps other ailments as well that we don't fully appreciate. Again, you know, the deeper we look at these diseases and these pathogens, the more side effects and long-lasting effects we often find. So another heads up, we need to protect ourselves and our animals, for that matter, against these vectors as best we can. And luckily, in our veterinary world, we've got some really great parasite preventatives for internal and external parasites. This is a crazy story, guys, and if I haven't scared you enough, this will do it. I often tell this story around Halloween time, but this young boy was developing some very bizarre signs and psychotic behavior. He was threatening to kill not just himself, but his family. And he was claiming to be the devil and things like that. And nobody knew what was going on. They just thought it was some, brain condition, some psychosis or something. But when he started developing skin lesions like these that we call stria, his doctors got him involved with the world's expert on Bartonella, who's a gentleman named Dr. Ed Breitschwert, veterinarian with a PhD. In addition to his veterinary degree, Ed has the dubious distinction of having diagnosed and tried to save his own father from Bartonella, which is known more commonly as cat scratch disease or cat scratch fever. And as it turns out, this child had cat scratch disease, Bartonellosis, picked up from a flea or from a scratch of a flea, the scratch of a cat that had been bitten by one of these infected fleas. And it had literally caused him to develop this acute onset of incredibly psychotic behavior. And I don't know if I showed it here, but yeah, if you take a close look at that last sentence in this paragraph here, I mentioned a 14-year-old boy underwent evaluation by multiple specialists for sudden onset psychotic behavior, hallucinations, delusions, suicidal and homicidal ideation. And I mentioned it earlier, that's where this boy was not thinking of just killing himself, but taking a few people with him. It is terrifying to think, and who would have ever thunk it, that the bite of an insect, the bite of a flea carrying this bacteria, or the scratch of a cat or the bite of a cat that's infected with this same bacteria could literally cause that type of disease in a human being. But it is true, it happened, it's real. And another reminder of many today why we need to protect ourselves and protect our own pets as best we can against these vectors of disease. Because guys, again, if they're not transmitting something we know of today, it's transmitting something we're going to discover tomorrow. And you don't want stuff like this, coming into your house. So I make the case, this is like The Exorcist. This kid, they must have thought he was demonically possessed. I mean, how horrifying is this? And right on the heels of this story, I saw a headline about a gentleman in a Native American reservation, Arizona, who had killed his own child because he thought his child was possessed with demons and wanted to expunge or exorcise those demons from his child. And my first thought, living in the world I do, was that, oh my gosh, I am well aware that on Native American reservations where there are such, abject poverty and so many stray animals and even owned animals which do not receive appropriate veterinary care or any veterinary care, there's a lot of parasites, a lot of disease issues, including things like Rocky Mountain spotted fever and tularemias and other things. That how possible is it that this child may have had that same condition that 14-year-old boy that Dr. Breitschwert got involved with had? And imagine if that was the case, how tragic. And, if I had the wherewithal, I would exhume that child's body and check for parasitic disease like Bartonella to see, because I am firmly convinced that's very likely what was happening here with that child. And sad to say, he was murdered by his own father. So strange things, guys, in our world. And again, you see hopefully why I'm so passionate and fascinated with this, because it runs deep. And again, that microbe that could shut down the world, as COVID-19 has done, this is our life. It's pretty crazy. So there's the story of federal charges for allegedly holding his 6-year-old son's face under hot water for several minutes. to cast out a demon. Well, quite likely that demon was a bacterial infection, sad to say. And I'm not saying that's the case, but in my opinion, I think it's likely. Another scary stuff, this is Chagas disease, a disease of Central and South America and other parts of the world, transmitted by, it's a protozoal disease. So remember, we talked about Coccidia, Giardia, Cryptosporidium, things like that, toxoplasmosis. This is a trypanosome type of protozoa, similar to what causes sleeping sickness over in Africa. Here it's transmitted by the Chagas bug, or this kissing beetle, assassin bug, as it's more often called. And beware, there are a lot of look-alike bugs that don't necessarily transmit disease, but they look a lot like the assassin or kissing bug. But in this case, this trypanosome, it's not sleeping sickness. It's a trypanosome. It's a protozoa that will typically infect the heart and cause a lot of pathology in that beautiful muscle that we know as the cardiac muscle, and ultimately debilitate, and in many cases claim the life, if they don't die of something else, claim the life of its victims. It does show up in dogs and other animals as well as human beings, and it's emerging disease. This probably accounts for more vector-borne pathology in the New World, so Central and South America, than any other vector-borne disease, quite likely, because the number of people affected or infected with this protozoa. But scary enough, it's emerging in the United States. Again, Texas being a hotbed for this, and these insects, many of which, when we test, are positive for carrying this particular trypanosome or protozoa, but also across that deep south tier, so Louisiana, Alabama, all the way over to New Mexico and probably Arizona. I've got a great picture of one of these Reduvidae or triatome beetles, these kissing bugs, on the side of a rock wall on one of Ted Turner's ranches that I happened to visit a couple of years ago doing some outline research. Got a great photo of this insect, but that's not an insect you want to be bitten by. And what's really fascinating with this insect and this natural history of Chagas disease, named for the South American physician who discovered it years ago, back in the early 1900s, is that the insect doesn't transmit this protozoa, this trypanosome, when it actually bites you. And you notice it's got a pretty darn pronounced proboscis there, guys. Its mouth parts are pretty significant. You do not want to mess with that. But adding insult to injury, it bites you typically in the night, and they call it the kissing bug because often the only exposed skin around many of us when we sleep is our face and head. So oftentimes this insect bites you around the mucous membranes of the lip or perhaps the eye. And then adding insult to injury, pardon my language here, but I have to be blunt, it takes a crap. It leaves a bowel movement, a bug bowel movement on your face right next to that bite wound. And then those protozoa either crawl, migrate into the wound, or more likely when you rub the wound because it's itching, you inoculate yourself with that protozoa. How disgusting is that? And then perhaps you're scarred for life with this infectious organism now in your system that can debilitate your heart and eventually end your life, or at least make your life really, really bad. So pretty scary. And what's concerning is there is now a case of this that's been documented from, of all places, the central United States, the Midwest, Missouri, where nobody was looking for this. Fortunately, because this disease is so bad, donated blood around the country is screened, among other things, for this particular protozoa. And lo and behold, this woman in Missouri with no travel history and no known exposure to any of these insects had donated blood. And it was discovered it was positive for this protozoa, this disease. And after multiple retests, just to make sure this wasn't some, spurious, anomalous finding, they figured out, no, in fact, this woman is positive for Chagas disease. Nobody knows how she got it, but it makes one wonder how much more of this is circulating. So even in places where we're not expecting to see diseases or ticks or bugs or, Chagas bugs, whatever, beware and protect yourself. All right. And as I've said here a couple of times, protect your patient, I call them patients, they're pets. I have zero tolerance for parasites of any kind on my animals and myself. And with that in mind, this is not too far off the mark from what I might look like when I go afield. And I'm becoming more and more aggressive about it as we go on. Many of us are wearing masks. Hopefully all of us are wearing masks and taking that seriously today with COVID. And that's just in our day-to-day lives, guys. When you start crawling under buildings and wrestling animals and handling carcasses and trapping mice on the airfields and things like that, cleaning pigeon guano out of a hangar, or, dealing with English sparrows and starlings and whatnot. There's a lot of risk. I pictured some of those things here: flies, fleas, ticks, mosquitoes, bacteria, worm eggs, microscopic worm eggs there. So I'm a big fan of DEET and permethrin. I'll much rather take my chances with chemicals, the fact that they might be hazardous themselves, but I'd much rather take my chances with those chemicals than any of these insects biting me. And I try to do my best to prevent inhalation of microscopic or aerosolized or atomized particles, whether it be fungal spores or bacteria or fungus, like with bacteria or viruses, like with COVID. I think the N95 mask is really important. If you can get a hold of one today, it's well worthwhile for much of what we do, and particularly in closed areas and certainly in confined spaces. But I'm a big proponent of PPE to the max, and I encourage you, don't ever be embarrassed by showing up in PPE. It reflects professionalism and awareness that many other people, while they might poo-poo it, they then can become the victims that you've avoided becoming. So you can go on YouTube tonight if you like, and as you're going to bed, watch videos of humans with rabies. That's that picture of that gentleman there with the profuse saliva. He's a dead man lying. He's not walking at this point, but he is a dead man because he has clinical rabies. There's no cure for that viral infection at that point. Other animals here that are known to transmit rabies here in North America: the barfs, bats, raccoons, foxes, and skunks. Those are the prime variants of rabies we see in North America today. And yes, dogs and cats can also get rabies from those other species, but we typically aren't seeing the dog variant, that dog strain of rabies, as much as we used to because of vaccination protocols and dogs and other things. But don't kid yourself. Dogs, cats, and many other animals, including horses, cattle, etc., can all come down. Woodchucks, etc., can come down with rabies. My point here is that in a wildlife sense, those bats, raccoons, foxes, and skunks, and to some extent coyotes, especially in Texas, are of special concern. But anywhere, anytime in our world, you could encounter rabies. And so again, there are vaccines for rabies. I encourage you, save your bucks. It's going to run you about $1,000 to get the series of rabies vaccines in advance. Protect yourself beforehand, and we'll all sleep better at night. But if you are bitten by an animal or have potential exposure to an animal that's suspected to be rabid, you very likely are going to get that vaccine very quickly across the course of several injections, to try to get your system immunized against the virus before it actually gets to your central nervous system and causes that clinical form of rabies. Because once that happens, if it happens, dead man, dead woman walking, bye-bye, out of luck. So very, very concerning disease, and one that we deal with, potentially every day in our lives. Rodents here pictured just for kicks and giggles: rats and mice. Just looking at this picture, I think of the 20 some odd diseases or more, probably way more than that these buggers can transmit. And yet, many of us are dealing with rats and mice and other rodents and vermin like this in our day-to-day jobs on airports or in wildlife settings. So just, again, protect yourself. Doesn't matter what the disease is or what the pathogen or what the vector is. You don't want to be bitten. You don't want to be poked by things. You don't want to inhale things you shouldn't, and you certainly don't want to swallow things you shouldn't. And those are the key ways we're going to get exposed: ingestion, inhalation, or inoculation/injection. Okay. How many of us have done this? This could be probably any one of us today listening in. Don't ever do this again. Wear appropriate protection, PPE. Remember that picture I showed? I would not go under this crawl space without a heck of a lot of caution and thought and protection and preparation. Because again, I look at this picture, guys, gals, I see about 50 different diseases that one could contract from this seemingly innocuous activity of crawling under a deck or a crawl space. So, all right, real quick, herd immunity. It's been in the news. This graphically is how that looks. The more patients we can get vaccinated or that develop immunity against a disease, the less likely it is that disease can transmit. And look, once you hit about 75% of the population being protected in one way or another, either having had the disease and surviving or being vaccinated, it becomes very, very unlikely that disease can propagate itself very successfully. 90%, again, yeah, maybe there's 1-2 two people that are closely linked or in close proximity, where the virus or bacteria or fungus, whatever, could jump potentially, especially with airborne entities. But it's very, very unlikely that even if that happens, that anybody else is going to get infected. So here's another way of looking at actually where those linkages are mapped out in red. And you see there 75%. Yeah, there's still a handful of cases, 90% even fewer, and 95% basically just one in this particular model. So again, that immunization, that herd immunity is so profound. I'm not convinced we're going to get that with COVID, especially if it continues to mutate and those mutations are resistant to the vaccines or don't respond to the vaccines. But hopefully we will, and certainly with the number of cases that we're seeing, it's becoming increasing likely. If there is going to be herd immunity, we will get there. All right, coronavirus is just real quick. SARS-CoV-1 2002, that was linked to civet cats, these odd rodents in Asia, and ultimately linked back to bats that gave it to the cats and probably other species. And they're not really cats, but we call them civet cats. MERS, Middle Eastern Respiratory Syndrome. SARS was the sudden acute respiratory syndrome. MERS is the Middle Eastern Respiratory Syndrome, linked to camels in the Middle East, but then also traced back to bats. And then SARS-CoV-2, of course, in 2019, linked to these pangolins, very likely, perhaps other species, but then ultimately also traced back to bats. So I love bats, guys. They're an important creature that we share the planet with. They're, really incredible mammals, but they are, notoriously dangerous. They carry about 60 different pathogens known to be dangerous to man. They're very adept at carrying viruses and not being affected by those viruses because of some internal adaptations they have that we talk about in our day-long course. But they are very, very dangerous, as are primates and rodents. Those are the next two groups of dangerous creatures in particular that we all deal with. And not to say other wildlife isn't potentially dangerous, but those are the big three groups: bats, primates, and rodents. But protect yourself against all things that we talked about: bites, injections, inoculations through bites or pokes, or getting poked by a needle after you drew blood from an animal and now you accidentally poke yourself as you're putting the cat back on the needle, or trying to get the needle into a blood tube, something like that. Inhalation and ingestion. Some amazing data on the coronavirus. I think in many ways it may prove to be the perfect pathogen. That's kind of how I'm looking at it. Survives freezing for extended time, survives heat, seems to for extended times. We continue to learn more about this. Why do I say it's the perfect pathogen? It's new. None of us really had pre-existing specific immunity to it. Yeah, we have immune systems that can fight things off, but none of us had that specific immunity to this particular virus. It's airborne. It's fairly infectious. So it has that relatively high contagiousness, relatively low fatality rate. So, rabies kills people and kills animals. And then, if that animal hasn't passed the virus on, that's pretty much end of the line for that virus in that animal. The rabies virus doesn't live very long outside of that host or in a dead host. So variable morbidity. So how sick does it make somebody? Well, it varies. So some people just have discomfort. Some people have death. And we can't predict, at least at this point, who's going to get which, who's going to respond in what way. And so there's a lot of uncertainty with that. But wait, as they say in the Ginsu knives and the bamboo steamer, wait, there's more. It's zoonotic. So it has the ability not just to infect one species, but many. We've seen many different species now, including cats, dogs, and lately gorillas, lions and tigers and bears, in essence, at the Bronx Zoo, infected as well, and mink, domestic mink for the fur industry. I mentioned also a wider variable incubation period. It can be a few days and perhaps many, many days, or perhaps even weeks. We don't fully understand this. That's the other thing. We don't know what we don't know. We make some assumptions as we go along, and sometimes our knowledge changes, and we have to change those assumptions and that guidance and those guidelines, those recommendations. But that's, the challenge with these newly emerging diseases. Asymptomatic transmission, now a concern, that people that feel perfectly fine and may feel like they don't need to wear a mask or to protect themselves or to protect other people in case they are shedding something, are in fact potentially shedding this. And so that's concerning too. It's not just people that are outwardly sick and coughing that might be sharing this. So again, and then mutations, and we've talked about that. I'm really concerned. And viruses have that tendency, especially influenza viruses, to mutate, like we saw with the Spanish flu. Avian flu became a swine flu, became a human flu in short order. That's a problem, and I'm really concerned with these mutations. Hot off the press, I mentioned this just a moment ago, gorillas now have been confirmed being infected by the COVID. Doesn't surprise me. I think we're going to see more of this. What's more concerning to me, perhaps, is that we now have a wild, free-ranging mink in Utah that was confirmed to have the SARS-CoV-2 virus. And that's really concerning because if this gets into wildlife that has a very high sensitivity to it, fatality rate, it could, potentially wipe out populations. But this also then, even without that, becomes potentially another reservoir. So, folks, I think COVID-19 is here to stay for a long, long time. And there will be other pathogens like it that show up. But yeah, something to watch. Lots of reasons to try to stamp this out and cut this, cut it off at the head, cut it off at the pass, and do our best to limit the spread of this disease. But the genie is already out of the box, and we're in for a long, wild ride. So strap in and get ready. Here's a little summary. Infectious diseases everywhere, all around us, all the time. Most infectious diseases is in fact zoonotic. We who work with animals, domestic, wild, or both, like myself, are at the highest risk potentially in all probability for these diseases. So we need to take the most aggressive steps to protect ourselves, protect our pets, protect our family members. I'm here to help. Really appreciate BSC, the Bird Strike Committee, letting us do this today. And I think we may be lined up for the next meeting next summer, or this coming summer, to do perhaps a slightly extended version. But in the meantime, please give some thought to the NACOA day-long course. If you've enjoyed this talk, we go into a lot more detail and a lot more discussion, and I'd love to have you on board for that. And I think with that, John and James, Dr. J will sign off unless we've got some questions, okay?
Thanks, Jay. Appreciate it. Chat's just starting to get active. So one of the questions we have so far is, do you find over time that these diseases get more contagious but less deadly than when they were initially or discovered? Or generally, is there no correlation to a disease's evolutionary progression and their lethality or impact on human health?
Great question. Very, very astute. And in essence, it depends. I think there's probably examples that we could cite that have gone either way, but it's hard to generalize. The one thing I said earlier, and I always like to repeat, is, we don't know what we don't know. And I don't think what I said along with that is I always assume the worst. And that goes along with seeing the headlines getting worse and worse typically. I always give these pathogens, these microbes, the credit and assume they're capable of a lot more than we realize. And just because somebody says, I go back to HIV and AIDS when that showed up on the scene, you can't get it this or that way. Well, it turned out you could. And then they said, well, it doesn't do this or that. Well, it turned out it did. Same with COVID as it emerged on the scene. It's going to be just like a mild flu, mild cold. It's going to go away. It didn't. Now we're seeing mutations. Now we're seeing domestic animals being infected. We've seen zoo animals infected. We've seen the spread of this around the globe. So again, always assume the worst. I think that's a good way. I like to describe myself as a cautious optimist or a hopeful pessimist. Take your pick. But the point is, be very careful with these things. Give them the benefit of the doubt. I mean, remember, we're talking about microbes, guys, that can live in space. They can live at 191 degrees. They can survive freezing for extended times. None of us can do those things. These microbes can. And by the way, little side note, for instance, with Lyme disease and other tick-borne diseases, didn't mention this earlier, there's really good evidence that when those pathogens get into those host vectors like the ticks, they imbue those organisms, those creatures, with like superhuman powers, so super acrid powers, super tick powers. So the normal tick that's out questing at the end of that blade of grass in the sunlight, looking for an animal to come by to attach to, has to go down into the leaf litter periodically to rehydrate and respirate and things. that tick that's infected with the Lyme disease bacteria doesn't have to do that as often. It's like super tick. It's like, tick on steroids. So dollars to donuts, the tick that's going to find the next host or victim is in fact the tick that's out there questing longer or more successfully, able to resist the colder temperatures that drive its conspecifics underground or into the leaf litter. And here's super tick with Lyme disease or Ehrlichia or Rickettsia or whatever, saying, that doesn't bother me for whatever reason. I'm able to stay out colder and stay out longer. So again, some scary things that the more we look at these things, the more we see that's those headlines getting worse. But yeah, great question. That gave you a long-winded answer. Just assume the worst and assume that these diseases probably are going to become more virulent, more common, more deadly, not the opposite. And let's hope they don't. But if they go that way, at least we said, hey, that's what I predicted. I'm ready for that.
All right, Jay, thanks. Next question is, other than wrapping ourselves in a full hazmat suit with respirators, what can airport wildlife personnel realistically do to protect themselves against these diseases?
All right, great question. And I go on record as recommending the ultimate, most aggressive, because I don't want anybody suing me later and saying, well, Dr. J said I could do this, that, or that and get away with it. So you have to make up your own mind what you want to do or what you don't want to do. I think at a minimum, tucking your pant legs into your socks so there's not an avenue of exposure through your ankles is important. I think, wearing long sleeve and gloves or veterinary, what we call sleeves for doing large animal rectal exams, and even taping off those closures at the wrist or the elbow, whatever, is a good idea if you're handling, carcasses or blood or tissue fluids. I think wearing a mask is very important, N95 or greater, ideally. Certainly a surgical mask or something like that we see a lot of people wearing today, if that's all you have available. But again, the more chances you take and the more you poo-poo this, it's brinksmanship. And all it takes is you and this invisible microbe and on the wrong day, the wrong time, the wrong place to get infected. So you can make up your own minds, but I'm a big fan, as I mentioned, of the permethrin and DEET sprays. Don't necessarily recommend any brands. I probably tend to buy off just because of the name recognition, but I'll go through a store and look at the labels of different canisters of spray or lotions or whatever, and try to find whatever one I can find that day that has the highest permethrin or DEET concentration or both, and use that liberally on my clothing and repeatedly throughout the day, my hat. And again, I try to use them as labeled. Some of these you don't want to put on your skin. Some it's okay to do according to the guidance. But I'm much more comfortable doing those things than I am considering getting bitten by any of these parasites, just because I know the havoc that they can wreak on one's health. So glasses too, safety glasses or eyeglasses to protect your eyes from splatter. Guys, again, urine, blood, tissue fluid, feces, semen, saliva, any of those things alone can transmit any number of different diseases, and from a dead animal or a living animal. And then if you're getting bitten by animals, insects, or the animals themselves, real high danger there with any number of different pathogens, or scratched. So again, the list goes on and on, all the great reasons why you just want to protect yourself very, very effectively and thoroughly.
Next question, Jay, is what level of research has been done on the potential broad dispersal of vaccines inoculates to wildlife in the wild to reduce the vector bank?
Not much. Great question and very perceptive. And I wish I had a better answer for you. But keep in mind, research of any kind costs money. And typically, wildlife is often at the bottom of the list in terms of general, research. In this case, yeah, arguably there could be a lot of importance. The oral rabies vaccine, the ORV program that the USDA has done over many decades in conjunction with a lot of public health departments along primarily the Atlantic seaboard, but also down into Texas, has been very effective at helping stem the tide. It hasn't eradicated rabies, but it's helped stem the tide of that disease in wildlife. That's had some benefit. But yeah, vaccinating wildlife is problematic, and partly that's due to the fact that many different wildlife species are potentially going to be consumed by humans, and so there's concern with using what we call biologics, these biologic entities or tools like vaccines, and certainly drugs, including even immobilization agents in wildlife. If somebody down the road is going to eat that animal, what are the implications there with that drug or that chemical in that animal? And so a lot of uncertainty, but yeah, not a whole lot of research being done on vaccines in wildlife at this point. But yeah, there's a ripe area for research, but lots of questions, and it might be difficult to really, getting domestic dogs vaccinated, including stray and feral dogs in areas where there's a lot of rabies, like India or other third world countries, is problematic enough. And if you throw in trying to get the wildlife vaccinated, it's a whole nother dimension. Not to say it's not worth pursuing, but certainly a lot of challenge. But yeah, very good question.
Next question, Jay. You used a lot of different terms across the board, but can you tell us what's the difference between bacteria, viruses, and microbes and their impact on us?
Yeah, great question too. So microbe is a catch-all term for any of those pathogens. We talk about bacteria, fungus, algae, certain algae, protozoa, prions, which technically aren't living. They're proteins. They're even less living than a virus, but I lump those into that microbe category because they can cause diseases. And then parasites, not necessarily microbial, things like the Balis ascaris roundworm or the dog roundworm or the flea or the tick itself. But microbes are generally a catch-all term for those smaller pathogens, things like the bacteria, the fungus. And hang on just a sec, folks. I'm in a hotel. Ma'am, I'll be right out if you don't mind. I apologize. Okay. Yeah, thank you. I'll be right out. The key thing to understand is that every one of those is different. And so bacteria are different from viruses. Viruses, are different from fungus. But I like to highlight them just to point out that really, the keep it simple, stupid sort of approach I like in my own life, being a simpleton of sorts, is just that, there's thousands of different diseases and microbes out there. But if we can narrow it down to one of those 6 or 7, that goes a long way then towards figuring out how we're going to deal with this, how we diagnose it, how we might treat it, and understand the other big challenge with zoonotic diseases in particular is we often don't have good treatments or specific treatments. It's just supportive care. Viruses, for instance, right? We don't have great antiviral drugs that are specifically labeled or indicated for, treating this particular strain of influenza or COVID. We have, a handful of general antiviral drugs we might use, but unlike, say, a bacteria where we've got antibiotics that might specifically be tested and labeled for that type of bacteria, that family or that genus of bacteria, we don't have that with a lot of pathogens. And that makes, treating these conditions potentially real challenging. And again, another reason to just be proactive and preventative. Don't get it in the first place, and you're better off. Then diagnosing a lot of these diseases is challenging too. We don't necessarily have good, reliable tests for every one of these diseases. So we go into a lot more in this detail in that day-long course. I hate to keep plugging that, but it's a great course. And we have much more time to talk about all of these things. So yeah, great questions, everybody.
Jay, now that you mentioned that, the course, I appreciate that. That's good information. But question is, are there any publications or documents for a wildlife professional out there commercially?
Yes and no. The CDC is a great source of information. There's some other sources that have good zoonotic disease information. There really aren't a whole lot of courses like we're doing here or through NACOA. I do some through the National Animal Care and Control Association for those that work with domestic animal control, the so-called dog catchers or animal control officers, as they prefer to be called today. So I do that training for a lot of them. And there are a lot of books and textbooks on zoonotic disease. Many of them tend to be more medically oriented, for medical professionals. But there are some, more in the general press out there if people have that interest. I'm not sure I can specifically recommend any off the cuff, but an online search would probably reveal a lot that might be of interest. It's a wide open field and certainly becoming more and more important and apparent every day that we advance here in life.
All right, thank you. And then we have a follow-up question from a previous question. What about existing biotic or potential predators, if you will, of these insect vectors?
John, I didn't follow that. Ask that again, if you would.
It's what about existing biotic or potential predators, if you will, of these insect vectors?
Well, yeah, I think I get the gist of that. That is perhaps a good thing. I guess we'd almost call that like integrated pest management potentially. Interestingly, animals like the possum are famous now for eating a ton of ticks in a given environment. So that's good. But on the other hand, possums can also be reservoirs for a lot of these different pathogens that we talked about, including Chagas disease. But yeah, and then bats, right? They eat a ton of mosquitoes and flying insects. So that's a good thing. But at the same time, bats can be notorious for transmitting diseases if we have that close association with them. So, but there are, I think, some ideas there perhaps that may develop. One of the ideas that goes back to the screwworm infestation or screwworms that used to inhabit North America and the southern states, Texas being a big one. Researchers were able to release sterilized males out into the environment, and they would breed with females and basically then kind of cut off the reproductive cycle of the screwworm in North America. And there's very aggressive screwworm monitoring. It's a fly. Its maggot actually feeds on living tissue, unlike most maggots. And we've been able to eradicate them from the United States, largely because of that technology. So there's some, options there where maybe we could do some kind of, biological sterilization or something of some of these vectors. And I believe some of that research is going on with some of these other vector species. It's daunting, but there's no reason things like that can't be pursued. And certainly, native wildlife that has that affinity to eat some of these vectors, that's, in my opinion, a good thing. Would seem to be a good thing, like possums eating ticks. Hey, more power to those possums. I hope that answers that question, if we got it right, John.
Sounds like it. So Jay, that was our last question. So this will conclude the webinar. And on behalf of Bird Strike Committee USA and the Executive Committee, Jay, I'd like to thank you for taking the time and effort and to share. We had a lot of great comments about the presentation. So we do appreciate you spending time with us this afternoon.
Hey, well, thank you. And thanks to everybody that hung in there with us. I'm at your service. And John, if you guys want to collect any of those questions that we might have missed or any of those comments, I'm certainly open to some constructive criticism and feedback. But appreciate everybody sharing this subject. And hopefully we'll come back, at the national meeting this next summer together in person for maybe a deeper dive into this mystique and mysterious world of microbes and pathogens and zoonotic disease. All right.
Exactly. I think, like I said, I think there's a lot of interest in this, especially where we are right now today globally.
All right. Well, everybody take care.
Just want to give everyone a heads up that there will be a link to the presentation. It will be a large video, but there will be a link on the Bird Strike Committee USA's Facebook page. And I would be remiss if I didn't put a plug in for the third Bird Strike Committee USA Strike Zone webinar, which will be on February 11th, same time. That will be, the title of that presentation is Out of Bounds, Managing Offsite Wildlife Hazards Within the Critical Zone. And that invite will be going out either later this week or early next week. And so we'll make sure that it's available to everyone that wants to participate. And with that, I'd like to thank everyone for your time and effort and spending spending an hour and a half with us over lunchtime or later in the afternoon with us. I hope you all have a really good day, and we'll talk to you in the near future.